In this video, we'll use this Excel spreadsheet configuration utility to do a quick walkthrough of how to set up PID in a WEG CFW-100 or 300 drive with very little explanation of why we chose the particular values we used. If you're already familiar with PID, it'll be all you need to get up and running. If you aren't that familiar with PID, or you just need a refresher, there are focused topic videos for each part of this. I'll pop those up as we go along to remind you they're available if you want to learn more about that particular topic. Our task is to get rid of all of the yellow cells by filling them in with the appropriate values. Gray cells are read-only cells, and I've marked the cells with default values that we don't need to change with blue, so you know just to verify they're still at the default value. Now before starting, go to parameter 900. A 4 says an application is currently running, so I'll go to parameter 901 and set it to a 0 to disable the soft PLC. Go back to parameter 900, and we see a 3 which tells us the application is not running. Now we can go to parameter 204 and set it to an 11 to reset all of the soft PLC parameters. The default soft PLC app is the PID function a drive uses. PID isn't actually in the drive, it's in the soft PLC. We'll talk more about that in the soft PLC PID video. My drive parameters are still set up from the previous video, so I'll just re-enter those here to clear the yellow boxes. Except for these two. We're going to change those in a minute, so we'll leave those in yellow to remind us. Okay, let's start with the setpoint parameters. We want the setpoint to come from the drive's HMI keypad, so we put a 0 here. I've added comments like this to most of the blocks to help guide you, but I'm not guaranteeing I typed everything exactly right, so please double check with the user manual if in doubt. We want our setpoint to be 6 psi, so I'll put that here. We can filter the setpoint if we're driving it from an analog input. We aren't, so we'll set it to 0. The setpoint video covers all of the various setpoint options. The red box reminds us that this is entered in engineering units, which means we need to configure the display for engineering units. Parameter 510 sets the units indicator in the HMI display. There is no indicator for PSI, so we'll set that to a 0 to display nothing. Parameter 511 sets the decimal point for all soft PLC parameters that use engineering units, so let's make sure that's 2 decimal places. Finally, we want to disable bumpless mode while we're getting things set up, so we'll put a 0 here. Okay, let's configure the process variable. Parameter 921 is where we tell the PID app that the process variable is coming in on analog input 1, and you can view the current process variable at any time in parameter 916. We have a direct or forward-acting system, so we put a 1 here. Of course, we need to set up analog input 1, so we tell analog input 1 it will be used as the process variable, and we'll use the default gain, 0 to 10 volt signal, offset, and we'll add a little filtering. We have a whole video set aside for techniques you can use to reduce process variable noise. Filtering is just one of those ways. Since the PID app expects the process variable in engineering units, we have to tell it how to convert the analog input to engineering units using PVmin and PVmax along with the min and max motor frequency. We derive those straight from the curves we created in the previous video. Now this is critical to your success, and frankly, this is the single most common thing I see folks screw up. So if you aren't real sure how to do that, then be sure to watch the process variable video where you'll see how simple it is to get it right once you understand what these 4 parameters represent and how they work together to give you the best possible PID performance. Our initial PID values are easy. We just use the default values. The PID tuning video will give you a better feel for what each actually does and how to optimize them. We're going to control the manual auto modes from digital input 2, and this is where we put the value we want for the drive's output. Down here, I listed the parameters we didn't use for this demo, just so you have them available if you want to use alarms, or add torque boost, or use a different type of set point, or if you want to use sleep mode. Well, we've gotten rid of all the yellow cells, so we're ready to give this a try. Over here is a list of all of the PID-related parameters in numerical order, which makes entering them into the drive super easy. We're not covering alarms in this video, so I just entered some values that will prevent alarms and faults. There's a whole separate video about how to use alarms and faults if you want to use those. Well, since all of the blue parameters are defaults, we don't need to change those, and the gray parameters are ones we aren't using, and most of these we set up in the previous video, all we really have to do is enter the new min and max drive frequencies and verify the rest are what we think they should be, enter just the 3 PID parameters, and modify these 4 alarm parameters so they don't interfere with this demo. I'll go ahead and enter all of the new parameters into this drive and verify all the rest. Okay, let's go to parameter 901 and set it to a 1 to tell the Soft PLC PID app to run. I'll go to parameter 900, and sure enough it's a 4, which tells us the PID app is running. Well, we're in manual mode, so I'll go ahead and switch to run, and I'll go to parameter 918 and scroll through some values. Remember, we set the min and the max motor speed to 25 to 50 Hz. So while we can set the manual set point to whatever we want, it won't actually do anything until it's between those 2 frequencies. If I go to 35 Hz, and sure enough the pressure is near 7 psi, exactly what we expect to see from the plot we created in the previous video. So could we have set up PID first, and then generated our curves using this manual mode where we manually control the output of the drive? Yep. Just widen up the min and the max drive frequencies before you start, and change them to the values you need before running PID. Great, manual mode works. Let's flip over to having PID control the output to automatically maintain 6 psi. And sure enough, with one valve open, the system settles out right at 6 psi. Cool. And remember, you can also see the process variable in parameter 916. How about 2 valves? Wait a few seconds. And yep, it settles out right at 6 psi too. How about 3 valves? Again, give it a few seconds. And sure enough, it settles out right at 6 psi. 4 valves. Sure enough, it ramps up and settles out right at 6 psi. How about no open valves? Sure enough, given enough time, it settles out right at 6 psi. Very cool. But there's a problem. It's taking around 10 to 15 seconds for the system to settle out. Can we make it respond faster? Yeah, we can. For example, with the PID parameters optimized, now when I open and close the valves, look how fast the system responds. It settles out at 6 psi within a second or two, even for the no valves open case. And it only took me a minute to optimize the PID coefficients. So if you want to learn how to do that, be sure to check out the PID tuning video where we'll do that, and we'll run some examples to help you get a better feel for how PID works. So again, all we really did was enter the usual motor and drive parameters, entered the set point and the PV min and PV max, which we got from the plot we created in the previous video, and we told the PID app to run, and everything just worked. How about that? This little configuration utility makes it super easy to visualize how to set up PID and helps make sure we don't miss anything. Now, if you're using the free WPS software for your drive configuration, then guess what? It has a built-in PID wizard that does the exact same thing, except it actually enters the values for you, and you can see the results on a trace in real time. Watch the PID wizard video to learn more about that. Click here to see all of the PID video tutorials for the WEG CFW series of drives. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's free award-winning support options.